So let's look at an example. Suppose that the market research firm is hired to estimate the percentage of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, they do own cell phones. Using a 95% confidence level, compute a confidence interval estimate of the true proportion of adult residents of the city who have cell phones. So I have a sample of 500. 421 of them have cell phones. So based on that, I want to make an estimate of all the people in the city who could have cell phones. All right. So this is a binomial distribution. How do I know? Because either you have a cell phone or you don't. And that's how we would write it. We'd say the distribution approximates the binomial. 500 is the sample size. 421 over 500 is the how many people own cell phones. Okay, and I show here what I do. Again, 500 is the sample size. X is the number of successes. So 421 over 500 is 0.842. So basically 84% of the people in the survey had a cell phone. And then again, to get the people who don't, the percentage of people who don't have a cell phone, it's 0.58. All right. So here's me doing it by hand, but I don't want you to do it by hand. Okay. So like I did the error bound margin, I got it. So then I could say that 81 to 87% of the residents have cell phone. I don't want you to do it this way. This is really kind of tricky. So let me show you. So I'm going to go to Minitab and I'm going to show you how to put it in. Okay. So I go to Minitab and I go to, let me make sure I'm doing this right. Yeah. So you go to stats, basic statistics, one proportion. So I'm going to do this as summarized data. So remember, this is where it gets a little bit tricky. Number of events is the smaller number of trials will be bigger. So there we go. So I put 421 for my events and 500 for my trials. My options, I'm keeping it at 95% and I'm going to keep it as exact. Okay, and you can see here, here's all the directions of how to do that. But I'm not, as I just said, keep it as exact. Let me show you something cool. If I go to options and if I do normal approximation, this means that binomial will start taking on that normal curve. And I want to do that because that's really easy for me to use these. Because remember, the central limit theorem says as I keep adding more data, it's going to make that really pretty bell-shaped curve. So let's do the normal approximation. Hit OK, hit OK. And look, it gave me almost the exact figures that I had by doing it by hand. So don't do it by hand. Use Minitab. It'll make it easier. And if I go back to the PowerPoint, I see the exact same thing. And then I can conclude that the lower bound is 81, the upper bound is 87, and that the error bound margin is 3. I did, the first slide you saw, I had 87.4. I think for proportions, let's keep it as whole numbers. It will make your life easier, and the error bound margins should work out pretty easy.